We are continuing with trig this week, so start by joining me with this warm-up, which reviews some stuff and expands upon some stuff that we've learned about trig. So this first question, if you want to pause it and try it on your own, fabulous, but I'm going to go ahead and get started, so when you're ready to unpause and we can go over it. So evaluate sine squared of 47 degrees plus cosine squared of 47 degrees. 47 degrees? Not special, right? It's not one of our unit circle values. It's not a special angle, so we don't know. And remember that this is the same thing as saying sine of 47 degrees squared, right? Like you're not squaring the 47, you're squaring the sine of 47 plus cosine of 47 degrees squared, and we want to figure out what that equals. So we kind of need to know, no, I can't switch colors, what the sine of 47 is and what the cosine of 47 is, right? And maybe you're grabbing your calculator right now, or you're plugging that into something and you're making sure your calculator's in degree mode, and that's great, right? But what do you know? I mean, you know what? Maybe do that. Maybe grab your calculator, check the mode, make sure it's in degrees, and go ahead and say, well, cosine of 47 squared, make sure you're not squaring the 47, make sure you're squaring the sine of 47, plus the cosine of 47 squared. Oh my God, I got 1. So let's think about this a little bit closer. Let's think about, we've got our handy unit circle. Whoops. We start right about on that positive x-axis, right? Like you start here, and I just want you to approximate, right? Oh, there we go. There's 47 degrees. So it's the unit circle, right? That means that the radius is 1. So when I focus in on this right triangle right here, I have, and I'm going to redraw that right triangle. This angle is 47. That's my 47 degree angle. This is 1. This is my x value. This is my y value, right? And oh, we get this point that's on the circle. That's x comma y. And we talked about how x was a cosine thing and y was a sine thing, right? Because when you go ahead and you do the sine of 47, you're going to get y over 1, right? And when you go ahead and you do the cosine of 47, you get x over 1, right? So you just get xy for this, cosine sine. So this is some point on the circle, sine squared of 47. So I want you to think like this. You've got cosine of 47 squared. Well, that's going to be some x value squared plus the cosine of 47. I messed that up. This is why it says sine. Plus x squared equals something. So when we do this length, right, it's a right triangle. This plus this squared, right? When you do y squared plus x squared, it's going to equal, we know what it's going to equal because we started off with the unit circle, right? This is all coming from a unit circle. So y squared plus x squared is going to equal to 1 squared. That's just the Pythagorean theorem, right? So I could have put anything here. I could have said, hey, what's the sine squared of 105 degrees plus the cosine squared of 105 degrees? It's going to equal 1, right? The sine squared of negative 42 degrees plus the cosine squared of negative 42 degrees equals 1. Right? So really, this is an identity, right? Sine squared of some angle plus cosine squared of some angle is always going to equal to 1. And that's just coming from the equation of a circle, right? Oh, x squared plus y squared equals 1, right? Or equals the radius squared. It's because 1 is the radius. right? So maybe you picked up your calculator, but this is something, and it's okay if this isn't really where you are. We are extending upon it a little bit, but this is an identity, a trig identity that you are going to be working with a lot next year, but you have actually been working with it probably even since geometry, like even when we did conics, right? So right here, this is just the equation of this circle. Okay, so kind of changing perspectives a little bit. What is the reciprocal of sine? So the reciprocal of sine is cosecant. Now it says, what notation is used for inverse? And I did this on purpose. Reciprocal and inverse are not the same thing, right? Inverse means that you are undoing something, right? We learned about inverse functions and how you find them. Remember all the fun properties of inverses. And if a function, this is actually one of them, I don't really remember what fun fact it was, like which number, but if a function's inverse is also a function, we can use inverse function notation, which is f inverse of x, right? So this notation, this little -1, is important for us to recognize that that is what we use when we are talking about an inverse function, right? But reciprocal and inverse do not indicate the same thing. Reciprocal is saying 1 over sine. This is you're solving, right? You're switching your variables. You're reflecting over, you're reflecting over the line y equals x. Let's see if my pen gets any better as this goes on. Right, so that's an important distinction to make, which is where we are focused with today. Right, so today, given the exact value of a trig function or a point on the circle, we're going to use inverse trig to determine the arc or angle measurement. Right, so depending if we want a degree or if we want a radian, but you're going to know the points. We're going to talk a little bit about calculator pieces. We're going to start off without a calculator, which means that we're going to be working with unit circle values. We're going to be working with special angles. So I just said this, right? Recall one of the fun facts about inverses where you switch x and y. You switch your variables. Let's see if I can write it this time. Switch variables. So here on the left down here, that's an A. We have a table that is f of x equals sine of x, right? With the special angles, right? We did this one last week, 2 weeks ago? 2 weeks ago. When x is 0, sine is 0. When x is pi over 6, sine is 1/2. When x is pi over 4, sine is 1 over root 2. When x is pi over 3, sine is root 3 over 2. When x is pi over 2, sine is 1. Not things that we're going to our calculator with. So if we want to graph the sine inverse of x, which is also sometimes notated as the arc sine of x, right? You got to be careful with this notation because if you recall, back in, I think March was when we were dealing with exponential and logarithmic functions. If I said 2 to the negative first, that's the same thing as 1 over 2. This is not indicating 1 over sine x, right? So this is not the reciprocal. This is inverse, right? This is another notation for inverse where you will see arc sine of x. So be careful with this. We're not going to look at this and notice, oh, that's like this. It's not the same piece that we're working on. Okay, so just be mindful or be careful with that. Well, what happens? Oh, darn. It's okay. What happens when we go to graph the inverse? Well, we're going to switch them, right? Now x is 0 and sine inverse of x is 0. Now x is 1/2. The sine inverse is pi over 6. So my input is the y value, and my output is the degree measure, the angle measurement, or the arc measurement, right? In this case, the radians. So my input, so it's almost like I'm saying, when I'm saying sine inverse of x, I'm saying, where is sine equal to 0? Where is sine equal to 1/2? Where is sine equal to 1 over root 2? Oh, pi over 4, right? You're thinking about it in reverse. Where is sine equal to root 3 over 2? Oh, pi over 3. Where is sine equal to 1? Oh, pi over 2, right? And this is quadrant 1. This is what we're looking at here. So if I said, well, sine theta equals 1/2, how can we get theta by itself? How can you solve an equation? When you go take yourself all the way back to algebra 1 and you're solving 1 or 2-step equations, if you've got x plus 3, here I'm going to write that. If you've got x plus 3 equals 6, and I said, hey, solve for x, many of you guys would be like, I subtract 3 from both sides because you're using inverse operation. Addition and subtraction are inverse operations. So sine theta equals 1/2, I want to get this theta by itself. I have to use the inverse of the operation that's happening. Instead of taking the sine, I have to take the sine inverse. That's the inverse operation. How can you undo sine then? So we're going to take the sine inverse of both sides, right? Just like I subtracted 3 from both sides. This right here, sine inverse of sine, those are inverse operations. They cancel out, meaning they equal to 1. So now I've got theta equals the sine inverse of 1/2, which is saying, well, where is sine equal to 1/2 on the unit circle? What angle has a sine of 1/2? Right here, 30 degrees, right? So the sine inverse of 1/2 is 30 degrees. But wait a minute. Isn't it also over here at 150? But a function can only have one output, right? I can't have an input. Think about that. If I put in 1/2, think about a graph. If you plug in 1/2 and I get 30, I can't also get 150. That's not a function, right? A function can only have one answer. So we need to restrict the domain, right, of the original function. Think about what a sine curve looks like, and I'm a little bit all over the place right here, but here's one period of my sine function. If I just graph this one period, it doesn't pass the horizontal line test. It's not one-to-one. Some of you guys even said that in your videos. It's sine and cosine are not one-to-one, so we need to restrict what theta can be, right, or what that angle can be. So sine, we restrict it to quadrant 1 if we're looking at positive values, and quadrant 4 if we're looking at negative values. Okay, so sine is defined, sine inverse is defined in quadrant 1 and quadrant 4. And I'm going to get a little bit more into this in a second. So you aren't going to be passing through something that's undefined, right? Like we're used to starting here, that's not changing, and going counterclockwise, right? So, okay, I can go counterclockwise, but now I'm in undefined land. It's not, I just told you sine inverse is not defined here. So stop, back up, and know that to get to quadrant 4, you're going this way. What does that mean about the angles down here, right? The sine inverse of negative 1/2, while we might want to be like, oh, well, look at that, that's 330. It's actually not. It's negative 30 degrees, because if you get to 330, you've got to pass through these undefined places, and we cannot do that, right? Think about when you're graphing it, it's almost like, let's get a new color. When I'm going to graph the original, and we're not going to worry about the graph of the inverse, you guys will get that next year. I'm going to worry about it up to this point, and then it's going to go down to this point. right? So that's like the restriction that I'm putting on sine to then graph the inverse. Okay? Very interesting. So sine is defined in 1 and 4. I would make a note in your notes. I'm assuming you're taking notes. Okay, so now let's take a look at cosine, right? And we're probably thinking, again, think about what the graph of a cosine function looks like. It doesn't pass the horizontal line test. It's not one-to-one. Its inverse is not a function, right? So we're going to have to restrict to this also. So in order for me to get cosine by itself, remember you're multiplying both sides by the inverse. You're taking the inverse. Sorry, not multiplying. You're taking the inverse of both sides. Right here is going to cancel out, and you're going to get theta equals the cosine inverse of root 2 over 2. So this is like saying, what angle has a cosine of root 2 over 2? Well, let's find that on our unit circle right here, 45 degrees. But where else? Down here, right? That wouldn't make it. I can't get two outputs. That's not a function. We're talking about the inverse function. So where is cosine defined? 1, not defined in 4. Cosine inverse of negative root 2 over 2, over here and over here. It will be defined in quadrant 2. So the part that I am going to be restricting my original function is to quadrants 1 and 2. So I'm just looking from here to here, right? That would then make the inverse of it. Once you continue on, it doesn't work. It's no longer one-to-one. But if I restrict the original domain, my result will also be just restricted. So cosine is defined in quadrant 1. Ooh, not an ideal color for you guys to see. 1 and 2. So sine was 1 and 4, cosine is 1 and 2. So you're not going to be giving me an angle that's outside of quadrant 1 and 2. So it's going to be somewhere between 0 and 180, or 0 and pi. Whereas, and I'll summarize that, sine will be somewhere between negative pi over 2 and pi over 2. Well, what about tangent, right? We can think about where tangent is defined. So you briefly looked at what tangent looked like, but it was like, woo, right? And it had an asymptote, and an asymptote, and then it did it again, woo, and an asymptote, right? And that kept going. So we want to look at where is this defined, and remember, we're not ever going to like cross over undefined land. So tangent of theta is root 3. This is like, I'm going to take the tangent inverse of both sides. This cancels tangent inverse of tangent of theta. So theta equals to the tangent inverse of root 3. So that's saying, what is the angle that has a tangent of root 3? You might need to think about the sine and cosine, but root 3 is going to result from doing root 3 over 2 divided by 1/2. So this is the sine. This is the cosine, if that helps you. This is the y. This is the x. So right here, that's 60 degrees. And right here, right, 2 negatives get you a positive. If I'm talking about that, remember all students take calculus. So here and here. But again, now I've got 2 outputs. So which one do I want? Quadrant 1, I don't want quadrant 3. What if I said negative root 3? Well, that's going to be true in quadrant 4 and quadrant 2. Quadrant 4 and quadrant 2. Okay, so what happens? Why? I said I can't cross through undefined land. Why can't I go from quadrant 1 to quadrant 2? Well, what is true right here on this line? Tangent is undefined. Right, so if you try to go this way, your tangent's undefined there. So think it's defined just in this portion. Right, in quadrant 1 and quadrant 4. And remember down here, my answer to this isn't going to be 330. I'm sorry, 300. My answer is going to be negative 60 degrees. So tangent is going to be defined in quadrants 1 and quadrant 4, right? But it's going to be from negative pi over 2 to pi over 2. Not inclusive, right? Because those are asymptotes. Or we can say it's from negative 90 to 90, not inclusive. Okay. So I'm going to summarize that at the top of this page before we get into this. And notice I'm not using a calculator. These are all special angles. We haven't picked up a calculator yet. So the restrictions that we are looking at. We did sine first. Sine, I'm going to say arc sine so you don't forget that notation. It is defined in quadrants 1 and quadrant 4, and it is defined from negative pi over 2 to pi over 2, or negative 90 to 90. And notice that's inclusive. Our cosine, was the second one we did, was quadrants 1 and 2. And that is defined inclusive, because it's never undefined, from 0 to pi, or 0 to 180. Our tangent, the reciprocal functions are going to follow with this, is defined in 1 and 4. And the difference between this one and sine is that this has asymptotes. So when we say it's from negative pi over 2 to pi over 2, it's not inclusive, right? Or negative 90 to 90. So I want you to think about this. The sine inverse, right? We're not picking up our calculators. Let's go ahead. Oh, darn. Okay, I was gonna say, let's go ahead and do these in degrees and these in radians, right? Let's do that. Now I feel badly. Hopefully you guys wrote that down. Sine inverse of root 3 over 2. So where is sine root 3 over 2? So what I like to think is this is positive. Sine is defined in quadrant 1 and 4. It's positive in quadrant 1. So I know my answer is going to be in quadrant 1. Root sine is root 3 over 2 at 60 degrees. Where is tangent defined? 1 and 4. Tangent's going to be positive in 1, so I know my answer is going to be in quadrant 1. Right? So this, you can think, what's going to result in 1 over root 3? Well, if I have 1/2 divided by root 3 over 2, that's going to result in this. So this is going to be my y, this is going to be my x, and then you can think about where that is in your unit circle. Right? So that's 30 degrees. Cosine is defined in quadrant 1 and 2. It's going to be negative in quadrant 2. So I know my answer is going to be somewhere between 90 and 180. Where is cosine negative 1? Well, that's going to be on a boundary, right? And that's going to be at 180 degrees. Okay, so now let's look at these in radians. So the tangent inverse of negative 1 over root 2, well, tangent is defined in quadrant 1 and quadrant 4. So this will be quadrant 4 because it's negative, right? It's the same thing, like 1/2 over root 3 over 2. I don't know, one of them is going to be negative, right? So this will be your y, this will be your x. It's actually going to be the same thing here, but instead of it being 30 degrees, we're going to have negative 30 degrees. Since I wanted to talk about it in terms of radians, that'll be negative pi over 6. Oh, no. Sorry. Ignore that. That's wrong. I'm just going to write my answers. Negative pi over 6. What about this? Cosine is positive in quadrant 1, and it's defined in 1. This is so wrong, and I'm very upset. Where is cosine going to be 4? Never. It's never going to be 4. That's not possible. Oh, there you go. Right? That's undefined. There is no answer to that. Cosine will only, like, if you tried to go into your calculator and you did cosine inverse of 4, which you might not know how to do inverse yet, it's going to give you an error. Not going to work. What about this one? Sine inverse of negative root 2 over 2. Or, right, so sine is negative in quadrant 4, because it's defined in 1 and 4. This is going to be a reference angle of pi over 4, but in the fourth quadrant, so it's going to give you negative 45 degrees or negative pi over 4. Now this is right. Okay. Let's see. Maybe try these on your own. Let's go ahead and do this. Let's do these in radians, these in degrees. Oh, let's do it in both. Let's do them both. Yeah, let's do that. Okay, so the sine is defined in quadrant 1 and quadrant 4. Since it's negative, we're looking at quadrant 4. So I know that my answer is going to be negative, right? Because I'm moving down to quadrant 4, I'm not going around the circle. This has a reference angle of pi over 4, so negative pi over 4 or negative 45 degrees. Sine inverse of 4. Where is sine 4? Sine has to be between 0 and 1, right? It never goes outside of that. So that is, oh, I'm going over there. Darn. Undefined. I'm just going to keep going this way. Cosine inverse of negative 1/2. Well, cosine is defined in quadrant 1 and quadrant 2. It's going to be negative in quadrant 2. So think about a reference angle here. A reference angle for one, like where is cosine 1/2? It's going to be at pi over 3, so it will be negative, no, it won't. 2 pi over 3. Right? Pi over 3 in the second quadrant is 2 pi over 3. Or maybe you're saying $120, sorry. Got distracted. Just depends if we're working with radians or degrees. Tangent inverse of 1 over root 3, so maybe you've got it at this point, but if you want to think to yourself, well, this is 1/2 over root 3 over 2. Right, so this is your y, this is your x. We're talking about quadrant 1 because it's positive, so this is going to be 30 degrees or pi over 6. Where's tangent 0? Right, that's going to be, 0 over 1. This will be your y, this will be your x. Where's your y value 0 between negative pi over 2 and pi over 2? At 0. 0 radians or 0 degrees. And finally, sine inverse of root 3 over 2. So sine is going to be positive in quadrant 1. Root 3 over 2. So it's going to be root 3 over 2 at pi over 6. Nope, pi over 3 or 60 degrees. Let's see if my answers are going to pop up in a weird order. Did I get them right? Woohoo! All right. Hopefully you got them right too. Okay. Now we're going to extend on this a little bit. Remember, composition of functions, so we're going to work from the inside out. So don't forget where things are defined. So right here, the sine inverse of 1 over root 2. Let's start with that. So the sine inverse of 1 over root 2 is going to be in quadrant 1. And it's going to be at, let's go radians, pi over 4. And then what's the sine of pi over 4? 1 over root 2. Oh my goodness, it canceled itself out. So cool. Do we think that always happens? Might be, right? But you got to think about where things are defined. That's where things might happen. Let's go over here. Let's start with this. The tangent inverse of 1 over root 3 is defined in quadrant 1. 1 over root 3, that's like 1/2 over root 3 over 2. So that tangent is going to be, let's see, I'm going to go radian style. 1/2 over root 3 over 2. It's going to be pi over 6. So then what is the tangent of pi over 6? Oh my goodness, it's 1/2 over root 3 over 2, which is 1 over root 3. Right? This makes us happy because we're noticing a pattern, doesn't it? What about here? Cosine inverse of 1/2. We're inclined to say the answer is 1/2, right? So let's see. Cosine is defined in quadrants 1 and 2. Cosine of 1/2 is going to be pi over 3. And then the cosine of pi over 3 is 1/2. Neat. We're still happy. We're only working in quadrant 1. What happens here? The sine inverse of root 3 over 2, we're still in quadrant 1. The sine inverse of root 3 over 2 is not the same as this, pi over 3. And then what's the cosecant of pi over 3? Which is like 1 over sine of pi over 3. It's going to be the reciprocal of this, 2 over root 3. Or you might be saying 2 root 3 over 3. Okay, right, so we had a lot of shortcuts we could be taken here. What would happen? Oh man, what would happen if I did something that wasn't in quadrant 1? Let's try this. What if I did the sine of the sine inverse of negative 1/2? Let's try this. Right, so right here, the sine inverse of negative 1/2. This is going to be in quadrant 4. Right? Negative 1/2 is going to be, so this will be the sine of negative pi over 6. And the sine of negative pi over 6 is negative 1/2. I'm gonna throw you for something right now. What if I really went for it and I said the sine inverse, I'm gonna go the opposite of this, of the sine of 2 pi over 3. Right? So still inside the alpha, notice I switched. So the sine inverse, does it work this way? 2 pi over 3. Well, 2 pi over, we actually know that the answer can't be 2 pi over 3 because that's not within the restrictions of sine inverse, right? So I know I can't just cancel this way. So the sine of 2 pi over 3 is going to be root 3 over 2. Right? The sine inverse of root 3 over 2, though, is going to be pi over 3. Right? So you got to be careful there with where you're taught. That's why you got to think about the quadrant. So think through it and how you're being asked it. And does your answer fit into whatever the domain is? Okay, so we're going to need our calculators here. And I think I'm going to do this. Here's my calculator. Oh, I think I can still write because I'm still recording, but where is my recordy thing? Oh, I guess I have to have that up. Okay. Oh, it won't let me just like write on this, will it? Darn. I thought I could write on anything. Oh, it's okay. It's okay, we're gonna go into our calculator. So, degree mode and radian mode. When you clear your calculator is gonna default to radians. So we wanna change the mode if we're working in degrees, right? So let's start off with radians. So sine inverse, and if it's a special angle, you don't need a calculator, right? So sine inverse, second sine, is how you get sine inverse of 1/2. No. 1/2. Enter. Oh, what do we know that to be? Right? We're in radian mode. Well, think logically. Sine inverse of 1/2. We've talked about this one. Well, sine is defined in quadrant 1 and quadrant 4. So I know that my result has to be in quadrant 1 because it's a positive. And sine inverse, so that's going to be pi over. So let's see. Pi over 6, right? Whoa. Right? What about sine inverse of negative 1/2? That's going to be defined in quadrant 4. So second sine of negative 1/2. Whoa. It's got to give me a negative angle, right? Oh my God. Right? That's negative pi over 6. Pretty cool, right? When I see arc sine of root 2 over 2, so second sine of second square root 2 over 2. It's arc sine still means the same thing. So I know that my answer should be root pi over 4. Right? Second pi over 4. Yay! Right? So for things like 1, 2, 3, and 4, we should not need a calculator and we should not be relying on one. So I assigned some practice textbook work that is only non-special angles. You're going to need a calculator, right? So for something like this, and let's say I wanted the degree now. Second, I'm going to go to mode and I'm going to change it to degrees. Second sine of 0.7, I should be in what quadrant here? I should be in quadrant 1. There you go, right? So 44.427 degrees. What about arc cosine of 4? I should know without going into my calculator right now that what's going to happen when I go into my calculator. Sine and cosine can't go above 1. So when I push second cosine of 4, check that out. My calculator's not broken. It's because it's undefined. It gives me a domain error. I cannot put in 4. Okay? So let's finish off with some of this evaluating. So maybe try these on your own. We'll check this out. We're back to no calculator. I just wanted to do a brief stop for calculators. Sine inverse of 1 over root 2, 45 degrees. The sine of 45 degrees is 1 over root 2. Right, what about the tangent inverse of 1 over root 3? One over root 3. Right, you can think about this and then see that that's going to give you 30 degrees, and then you're really just doing the tangent of 30 degrees. Cosine inverse of 1/2. The cosine inverse of 1/2 is going to be 60 degrees, and the cosine of 60 degrees is going to be 1/2. Didn't I already do these same ones? Did I? Is it the same ones? It is. Oh, I just plugged my slide in. So you know what? Let's do something for fun. Let's change this and say that this was -1. And this was -1. And this was the -1, and this was the -1. So let's go the opposite way like I was talking about before. So the sine, no, but that's not going to work. I should just change the slide completely. Okay. Sine inverse of the sine of pi over 6. I might as well just change this. It's okay. So now we're saying the sine inverse of, well, what's the sine of pi over 6? 1/2. The sine inverse of 1/2 pi over 6. Okay, right? So that just canceled, same way. Let's do 3 pi over 4. So the tangent inverse of the tangent of 3 pi over 4. So the tangent inverse of the tangent of 3 pi over 4, think about the unit circle, that's going to be -1. The tangent inverse of -1, though, that's defined in quadrant 1 or 4. Well, it's negative, so it's going to be quadrant 4, which means it's going to be negative pi over 4. And if you wanted to check in your calculator right now, you're going to see that you're going to get negative 45 degrees or negative pi over 4 radians. What about this? Cosine inverse of the cosine of 3 pi over 2. So the cosine inverse of the cosine of 3 pi over 2 is going to be 0. The cosine inverse of 0 is going to be, oh wait, oh no, is going to be pi over 2, positive pi over 2, right? Because it's defined from 0 to pi. Right, so we were good. When we were in quadrant 1, it cancels. We were good going the other way completely, right? Before I switched it to being what you're plugging in is the sine versus the sine inverse. But when we're in quadrant 1, we're good. It's canceling. When we're not in quadrant 1, that's not what we are. We're thinking about the reference angle and then taking the negative of it is ultimately what's happening. And I'm just not going to do this one at all. Let's say we wanted to do the cosine inverse of the cosine of five pi over 4 or 5 pi over 3. Yeah, let's do that. So the cosine of 5 pi over 3 is going to be 1/2, and the cosine inverse of 1/2 is going to have to be in quadrant 1, isn't it? The cosine inverse, so 5 pi over 3, thought about that. I got 1/2. The cosine inverse of 1/2 is going to be pi over 3. Right? So these are a little bit more challenging, but I do think it is good for you guys to start thinking about some applications of inverse and why you're not always just assuming things are canceling. Okay, so let's finish off with this check for understanding. So I want you to pause the video and try these on your own and then come back together and check your work and see where you are with this and what you might need to practice more individually. So now that you've had an opportunity to try them, the cosine inverse of root 2 over 2. Let's do odds in degrees and evens in radians. And I guess I could really do both, but that's okay. Cosine inverse of root 2 over 2 is going to be 45 degrees. I'm just going to do the odds. The arctangent, so the tangent inverse of negative root 3, it's going to be in quadrant 4, so I know it's going to be negative. And I'm going to have the sine will be root 3 over 2, and the cosine will be 1/2, so negative pi over 3. I'm sorry, negative 60 degrees. 5. So really here, I want to know, I'm going to think about the sine inverse of 1 over root 2. What's going to be 45 degrees? Right, that's going to be in quadrant 1. And then 7. Let's start from the inside here. Oh man, I made this one hard. Sorry. Cosine inverse. Let's do this. Let's think about it as a right triangle. So I'll call this theta. Cosine, this will be 4. This will be 5. How do you find this? Oh, we know this, right triangles, Pythagorean triples, that's a 3. So what's the tangent of theta? Oh my goodness. It's going to be 3 over 5. No, it's going to be 3 over 4. That's a challenging one, right? Because that really wasn't what I was even talking about. That's okay. Sorry, I don't think I intended to put that there, but never bad to practice. And let's do these in radians. So the arc sine of -1, so where is sine equal to -1? It's going to be at negative pi over 2. Where is sine equal to 1/2? That's going to be in quadrant 1. So that will be pi over 6. Arc cosine, so where is cosine -1/2? It'll be in quadrant 2, and that will be at 2 pi over 3. I don't know if challenge is the right word, if it was just a little different. It has 2 eyes. Yay. Okay. So I encourage you to use the practice resource in the answer key that I have posted for this. I think that's a great way to continue to practice this and just continue to summarize for yourself where are each one of these defined, and use your calculator to check, but don't rely on your calculator, right? We want to get to the point that we don't need our calculator when we're dealing with unit circle and special angles. So what you just did in this lesson was given an exact value of a trig function or of the point on the unit circle. You are able to use inverse trig and use inverse operations in order to find an arc and an angle measurement. So thanks for watching. Let us know if you have any questions.